In section 10.4, we continue to look at solving quadratic equations, and now we're going to do that by using square roots. So remember that typically we want a quadratic that's set equal to 0. Ax squared plus bx plus c equals 0. One time when that's not true, though, is when we have b equal to 0. So if you have an x squared term, regardless of the coefficient, and you have some constant, then we're not actually going to set it equal to 0, but we want to get the x squared by itself. So let's see how this works. So in the first case, this is ideal, where we have x squared by itself already, and then a constant on the other side of the equal sign. And of course, to undo the squaring, actually I'm going to rewrite that so I have a little more space. X squared equals 25. To undo squaring something, we of course take the square root. So to get x by itself, we want to take the square root of x squared, and then we'll take the square root of 25. Now remember though that 25 has two square roots, a positive and a negative square root. So we want plus or minus the square root of 25. And so we end up with x by itself, because the square root undoes the squaring, equals plus or minus, and then the square root of 25 is 5. In number 2, we have negative 2x squared equals negative 32. We want the x squared by itself. So divide by negative 2, so that negative 2 will cancel negative 2. That means we also divide the right-hand side by negative 2, and we get x squared equals a positive 16. Take the square root of each side, and we get x equals, remember, plus or minus the square root of 16 is 4. Okay, number 3. Solve 4x squared plus 5 equals 14. So here we have a couple of steps to take. We have a multiplication and an addition. So working backwards, we want to undo the addition first. So we'll subtract 5 from each side, and we get 4x squared equals 14 minus 5 will give us 9. Then divide by 4, and we get x squared is equal to 9/4. And then of course we'll take the square root of each side, and remember that if you have the square root of a fraction, you can apply that square root individually to the numerator and then to the denominator. So we have the square root of 9 over the square root of 4, and so this means we get x equal plus or minus 3 over 2. Alright, number 4, again we have a couple of steps to take here. We have 1/2 x squared minus 4 equals 14. So let's undo that subtraction first by adding 4 to each side. So we have 1/2 x squared equals, that's a squared, equals 18. And then to undo the multiplying by 1/2, we multiply by the reciprocal, 2 over 1, or just 2. And we end up with x squared equals 36. Fortunately, that's a perfect square. So we end up with x equals plus or minus the square root of 36, which is 6. Okay, number 5, solve x squared plus 20 equals 16. So let's subtract 20 and see what happens. And we get x squared equals negative 4. But there is no number, no real number, that we can multiply by itself and end up with a negative. And so at this point we say no solution. So there is no value of x as far as real numbers go that will ever make this equation true. Okay, number 6, solve 3x squared minus 7 equals 32, and round your answer to the nearest hundredth. So that's kind of a clue that this won't be an integer more than likely. So again, we have a multiplication and a subtraction. We'll undo the subtraction first by adding 7. So we get 3x squared is equal to 39. And then divide each side by 3, and we get x squared equals 13. Then we'll take the square root of each side. So that means we have x equal plus or minus, so this will lead to x squared equals, x equals plus or minus the square root of 13. Now if we were asked for an exact answer, we would be done, because this radical cannot be simplified. But because we're looking for a decimal, I'm going to grab a calculator and calculate the square root of 13. And just for completeness, I'll close out the parentheses, and we get 3.60555. And notice we want to go to the nearest hundredth, so 2 decimal places. So we go to that 0 and we look to the right and we have 5 or higher, so that rounds up to 3.61. So we have x equal to plus or minus 3.61. So there you go with solving quadratic equations by using square roots. Good luck.